Hello, everyone. Welcome to this fourth edition of our monthly EOSC Ask Me Anything webinars. I'm Katrien. I'm leading some communication activities in the EOSC Future project, but today I'm just here to introduce everyone and then let them give their great presentations. Over the past month in these sessions, we've had speakers from different EOSC projects who presented solutions for mid to long-term data storage available through EOSC, software solutions that you can find on EOSC, and compute services. Maybe you already tuned in for those sessions. If you didn't, or you'd like to share what you've learned there with someone else, you'll find the recordings on the EOSC Future website and on the EOSC portal YouTube. So I'll share the links to that in the chat later on. Today, we're here to talk about different types of aggregators. And before I present today's speakers, I have a word on questions. So there'll be some time to take questions from you at the end of the session. And we'd like you to submit those questions via Slido so that they don't clutter up the chat and we'll have them all in one place. You'll see on your screen now a QR code that you can scan and a link that you can follow, and we'll post that in the chat as well so that you can post all your comments or questions, any feedback over there. Then today, after an introduction to aggregators that are available through EOSC by Oscar Corcho from the Universidad Politécnico de Madrid, and a presentation by Fulvio Marelli to support that as well. And for you from the University of Oslo will present some of her day-to-day needs as a climate scientist. And then afterwards, we'll have a set of presentations on aggregators that are available through EOSC with Paolo Manghi from OpenAir presenting OpenAir's graph services. Raul Palma from the Poznan Supercomputing and Networking Center will be presenting RO Hub. Alex Ioannidis from CERN will present Sonodo, and Claudia Martens from the German Climate Computing Center will present B2Find. We're wrapping up again with Anne Fouillou, who will present how she's using those services and those types of services in one of her workflows. So without further ado, Oscar, the floor is yours.
Thanks for the introduction. I will now go into sharing my screen. Okay, so thanks again for being around with us. As we have been already commenting, that the main idea of today is really seeing some of the services and some of the experiences that are related to the use of what we call aggregators in EOSC. Yeah? So just without further delay, I mean, you have already seen this one. I'm in charge of like going into this journey and started the introduction, yeah, on this topic. And I mean, as in any other presentation where we are talking about EOS, it's always useful to go back into checking which are the main elements that we have. I mean, which are the main elements in the vision, and how this will be connected afterwards with what we are offering or what aggregators are actually offering. Yeah. So I mean, like taking some of the pictures that appear in the strategic research and innovation agenda of EOSC, and also I mean coming from other colleagues, we always have to consider this view of EOSC as a federation of infra and research infrastructures for data and services, always with a very clear view on interoperability, with the EOSC interoperability framework as one of the assets that moves forward or tries to make sure that all the services and resources that we are providing are interoperable, and most importantly, considering multiple providers. Yeah. So all this ecosystem, all this federation is being under development, yeah, in the context of EOS Future, but all plus all the other sister projects that you can see over here in the future, in the footer, and the ones who are involved in this webinar. Yeah. Taken again, I mean, like from one of the presentations that we had last week. Yeah, in this case, I was taking it from John Seffertson from CEST. These are some of the elements that are already being made available or are in progress in the context of EOS Core, the core set of services. Yeah, and I think that, I mean, if we look at which are the main components, the main elements that we consider there, we will be talking about authentication and authorization. We will be talking about metrics that allow us to account for the impact that we are having. Also, all the catalogs that have to do with research products and services. We have also those elements related to monitoring, which are very important for those providing services and generating resources that are also made available in EOSC. We have obviously the help desk, yeah. I mean, and we are now contributing to part of this as well. And finally, things that have to do also with the order management, yeah. Whenever we are asking for services, yeah, and as users, as scientists, as we will see later with the presentation from Anne. Based on this, I mean, what is what we are going to be talking today about? I mean, many of these elements that we are going to be talking about today are those available in the marketplace, which are built on top of EOSC Core. And I mean, the main idea is that they will be offering progressively a growing set of services, resources, exploiting fair data, services, and so on, yeah? For instance, I mean, I just took the opportunity to just highlight some of those services that we are already providing in the project that I'm kind of representing right now over here, although, I mean, this is a joint effort, as we have already said, yeah? Like Arrow Hub, and Raul Palma will be talking about this a little bit later today, or the Adam platform, the Adam space, the enrichment APIs. So these are some of those services that you will be able to find in the marketplace and that could belong to this category of aggregators, yeah? So if we move into the view that we have from the EOSC portal, we can see that if we click on services and resources, we have many categories over there. Today, we are actually going to focus on this one, on aggregators and integrators, just part of what you could find under that part of the menu, yeah? So I think that Fulvio is with us as well, our colleague Fulvio. Fulvio, are you around?
Yeah. Hello,
okay.
Hi everybody.
Oh.
So yeah, just to have an overview. I mean, this is taken from the literature about aggregators. So when we talk about data aggregators, is the capability of those kind of services that allow you to summarize data that is coming from multiple sources. This means that it is a place where you can, for example, like store, or you can index your data, you can process your data. There are many kind of functionalities. So aggregators is a quite of a very wide kind of definition. The idea is that it's a service that allows you, again, features to collect, to process, and present aggregated data to the users. Basically, the term is coming from the business domain. Okay, so where you when you do data aggregation is basically used to provide statistic analysis of groups of people and to create summary and data for business analysis. If you can move forward. So again, these are some of the main kind of functionalities that an aggregator could provide you, like the search and discovery for scientific data, or data annotation, customized data projection, online data processing, data storage, and data analysis. And there are many others. But so you will have a look through those. At the time being, there are 24 data aggregators which are available into EOSC. I've been trying to put all their icons over here. You can just go into the marketplace, go on aggregators and integrators, and you will find all these. You know, 9 are generic, while some of them are, of course, dedicated to the specific domain, to some specific domain that could be, for example, in our case. And the work that we are doing in Reliance and with RoHub, we are mainly working in this domain with earth science. Okay, so our focus today is going to be on research lifecycle management. So this is, you know, a day in a life of a researcher. How is research lifecycle management managed actually in the earth science domain? So we are going to have this example by Anne, and we will try to highlight, to show some aggregators, and we will try to highlight how these services can improve, and how the final users in this particular case, an earth scientist, can benefit from those. So just to give back into the agenda, we will have a very small elevator pitch about what matters in the life of a climate scientist by Anne Fuyu from the University of Oslo. Then we will dig through some aggregators, so Rohab, Zenodo, Open Air Graph Services, B2Find, and then we will get back to Anne and she will show us a concrete use case showing how these services are helping her with her everyday job. So let's move to the next slide and let's move, yes, the word to Anne. Thanks.
Mm-hmm.
Okay, yes, you can move to the next slide, and I will show you what matters in the life of a climate data scientist. And I try to summarize here the three most important aspects in my daily work. And the first one, which is on the left-hand side, it's to find and access relevant resources. And what does that mean for a data scientist? For us, published papers are not sufficient. So we write programs, we develop new methods, and we analyze data. So for example, if I find a Jupyter notebook exemplifying the usage of data I'm interested in, it can significantly speed up my work. So then we have the second, which is in the middle of the slide, which is reproducibility, and reproducibility matters for me. For instance, if the Jupyter notebook I found here in OpenAir, the first thing I want to do is to rerun it, and I want to check the results to make sure I start on a sound basis. So then comes the most interesting part of my job, which is to create derivative work, because reproducing an existing research outcome is not very exciting. But then I will probably start using different data sources. I will update the methods. And here, the collaborative aspect is very, very important. It's a must. I really never work alone. And what I want to do is I want to share what I do now and avoid having issues such as it works for me, but it doesn't work for others, or vice versa, which is usually the case when I work locally. So for this, working open and using EOS services, so such as the Adam platform, which we use in the Reliance project for accessing data, the EGI notebooks and the EGI data hub for sharing the data, that's the trick. And then finally, this is the third part on the right-hand side of the slide. Working open, it also means I need to make my work findable and accessible, but not after when I publish, but right now. So for this, I use research objects and I use Rohab portal from the Reliance project. And what I do, I really aggregate and share all the resources I use. So all the input data, which I can get from different resources, for instance, from Copernicus, from the Adam platform, for any other data source provider. And I will also share the tools, so the link to my Jupyter notebooks or the tools to my software and the data I produce. So everything needs to be accessible by everyone at any time. And then when we are ready and we work together, at some point we will, this is what we have at the right-hand side at the bottom, I will publish my research object, for instance, into Zenodo. I will get a digital object identifier, and I'm hopefully will be able to be found, reused, and cited. So one thing which is very important, that everyone who works on the research object will be a collaborator. And in addition, the person who initially provided the Jupyter notebook will also be a collaborator. So it will, he or she will be rewarded for sharing the work. And what you see on this slide, this is what I will demo later today. And that's it for me.
So we give the floor to the next speaker. So finally, I mean, you were rearranging a little bit the set of speakers. So who is going next? Raul or?
I think
Paolo, I think it's Paolo because.
Okay, Paolo, yeah, go ahead.
Hello, so is it my turn?
Pronto?
Yeah,
Yep.
So because you need to leave, right, Paolo? So just. Okay, no problem. So shall I share my slides or shall I go through yours?
Just share your slides, yeah.
Okay. Oh, 1 second, I'm sorry. Sara, sono in call, sto parlando io. Ciao. Ti metto l'acqua, ciao. Sorry, wife on the way to home. Okay, so I show and share. It's disabled. I cannot share my screen.
And I'll try to help you out, Paulo.
Okay, now I'm co-host. And I cannot find, of course, what I want. Come on.
I think in the meantime, while Paulo gets his PowerPoint working, maybe a reminder that if you have questions, you can always post those to Slido, or if you put the link in the chat. Now, yeah, we can see your slides, Paulo. Yeah.
Can you now?
Yeah, we can see them and we can hear you, so all good.
Okay, so good. Open Air Resource Graph and services, but let's focus on the resource graph itself. So the idea behind the Open Air Resource Graph is to build what you can refer to as a global CRIS system, so current research information system. So a knowledge graph that contains metadata about research outcomes. You can see here a high-level metadata model, so research products, about publications, data sets, software, etc., and all the links that we can find out there among this, plus the relationship of the research outcomes with other elements of science related with the financial parts. So the organization and the author themselves, the projects, the streams, and the funders where these are available. The idea was since the beginning to provide the data, the raw data, open data, available for others to not only build discovery services, like Fulvio was saying, but also research impact services, research trends and analytics, and so on. And to do this in an open, as much as possible, open fashion, by collecting data from data sources, from other knowledge graphs, from registries out there like ORCID, and so on. This is a summary of the groups or the classes of sources that we are included in the graph today, which range from software, research software related data sources, so GitHub, software heritage, but also data sources that are specific to the domains like the Elixir Bio tools or the application databases from the GI. It ranges, of course, to open access publishers, but also non-open access publishers with agencies like Crossref, for example, and includes a lot of registries. You can see on the right side. So registries here are intended as those services that are not only providing metadata, but also they mint in the identifiers. So they maintain the identity of the entities. It's the place where you want to go when you want to have authoritative information about an entity, like ORCID, Readly data, Open Door, Fair Sharing, which are related with data sources. Then we have domain-specific data sources, like the ones coming from the communities. Arrow Hub will soon become a data source that is being presented by Raul in the next stage. But we have so many other examples, like thematic repositories, the PubMed, Archive, etc. We are also collecting from other aggregators. And examples of those are here left side at the bottom, like La Referencia, DOAJ. These are aggregators of publications. But then we have so many others, like datasets, like, for example, B2Find, that I guess Claudia will present later on. Is doing an excellent job in collecting metadata from certain communities and building an aggregation of that. And we collect on top of that. So keeping both the notion of the data source from which we collect the metadata and the data sources behind it, because we want to provide all the visibility that is needed for those who are using the data to understand and interpret it. So it's all about metadata, but also about links. This is a key part. So the added value of the graph is that it is a graph, in fact. So we are also keeping the links and the semantic links between all the different objects and how these are connected. So this is a high-level view of how we construct it. So we have the data sources on the left hand. These must comply to standards defined by the communities, which we have included under the umbrella of the so-called open-air guidelines. We are collecting from there, validating, also providing feedback on the quality of their compliance, so the compliance degree and level. And we build a graph that is raw, meaning that we have harmonized the data, but we still have to draw some conclusion about it. In fact, the next stage is the deduplication, where we are bringing together metadata records describing the same entity, but coming from different sources. And we also perform full text mining after the duplication. Full text mining is about mining the full text that we are collecting when this is possible, thanks to agreement with publishers, but also thanks to the crawlers that we're building. We have now about 15 million, and we are inferring a huge amount of links, which are extremely useful because they are not available through the metadata records originally, namely links between publications and projects, publications and data sets and projects, and publications and software. This is one of the most important results, in fact. Out of that, we build a graph, which is periodically dumped for everybody to access and made available through open APIs. APIs that are today used by the Commission when you are reporting your results, and also by Scopus, Cyval, and many companies that are using them outside. Plus, recently, the European Open Science Cloud, which we ground on this, the EOSC Resource Catalog. So how is it placed here? Provide X, the service that we offer called Provide X, as a sort of gatekeeper about on the onboarding of resource products into the EOSC. They will become part of the open resource graph, as well as the services that are being onboarded in the EOSC service catalog. And this will give life to the EOSC resource catalog as a whole, where services will be linked to publications, to data sets, to software in many ways, and to projects, of course, in many ways, with different semantics. So it's not just the is hosted by or collected from a data source, but it will also be interesting to fetch, because we are building mining algorithms, for example, information on how a service is being mentioned in a paper. So we have already found interesting links between the papers and the services. And again, this will be made available through the open APIs to build services such as discovery, monitor, etc. for the communities. Most of this is already available, production ready, but through the OpenAir Nexus. And in September, also the EOSC Resource Catalog will be available for the EOSC Future project, based on the aggregation of the OpenAir graph. So I'm done. So if you have any questions, that will be at the end, I guess. I hope I was in the 10 minutes.
Yes.
I think it was, and I think we now give the floor to Raul, who will continue with Oral Hub.
Okay, thank you. So thank you, Paolo, and for the first presentations. Okay, so I'm going to talk about RoHub platform. So before going directly into what is RoHub, I just need to give a bit of context here, background of what are we doing with this RoHub platform. And this starts with the research and information lifecycle that, as you probably know, is a continuous and interactive process that is followed by researchers to conduct, validate, and disseminate scientific knowledge. Independently, I mean, there are many different domains, but in general, we can summarize the different stages in something like the thing that you can do, you can see in the slide. So you start with some discussion and analysis of some kind of shared results. Then researchers, based on that, create new ideas. They do some experimentations. They deliver some new results that need to be validated. And finally, they make publication of these results that are accessible for further cycles in the dissemination of scientific knowledge. Of course, during the course of this cycle, resources are being produced and consumed. There are potentially in many different locations, in many different repositories, and in many different formats, and accessible via different methods. So there is a need for mechanisms to manage the data, the methods, and other resources that can, on the one hand, enhance the visibility of the scientific breakthrough, their scientific results, encourage their reuse, and foster a broader accessibility to those results. So questions like how to support and capture the life cycle of scientific investigation from the data collection to the execution of the methods, to the publication of these and the research infrastructure information that related to these investigations. All of this is how we can capture this information, how to provide a unified entry point to all the resources that are related to this particular work, or how we can validate and disseminate scientific knowledge. Of course, making sure that we receive proper credit and citation, even if we are, disseminating individual parts of the research, not like just the paper, but also the data, the methods, and individual parts of the research. And at the end, of course, how to preserve the scientific knowledge to support the reuse. And this is where the research object comes into life. So the idea of the research object was to account and describe and share everything about your research, including how the things are related to each other. The main three elements of the research object is the identifier. So it has to be a permanent identifier. It can be, of course, a DOI, but also any other kind of permanent identifier. The aggregation of resources, any kind of resources that are related to the investigation, from the hypothesis, the data, the methods, but also the people that are involved. And of course, annotations that are understandable both by humans and machine, that are providing descriptive metadata, provenance of executions, versioning information, and so on. So based on that, we created the ROHAB platform. Started from early 2010 with initial proof of concept, let's say. Then we delivered some kind of prototype in the project that was called Everest. And now, as part of Reliance project, we are bringing this into production into the EOSC environment. So ROHAB is providing a holistic solution for the management of the research objects, enabling the storage, lifecycle management, and preservation of the outcomes, share and make these resources available to others, publish them and release them through DOIs, and discover and reuse pre-existing scientific knowledge. So ROHAB is the reference platform that implements natively the RO model and paradigm. And of course, we support different stakeholders, but our primary focus is always scientists and researchers. So this is, on the right, you can see how it's accessible from the EOSC and the current numbers about research objects that you can find in the portal directly. Some of the main features or high-level features of the research management platform is the creation of high-quality research objects. So that means that we are providing functionalities to assess how good in terms of quality is a research object based on community expectations, for example, to reference and share and preserve scientific studies, including, not only resources themselves, but links to external resources that might be, of course, dispersed in different locations. Allows the collaboration of colleagues, discover new knowledge, and the exploitation of metadata that is provided both explicitly, but also that is automatically extracted from the content of the research object. We also provide, of course, capabilities to manage the evolution. That means that you can generate snapshots, releases through the lifetime of your research, and you can make also forks, like, creating a new branch of research based on existing one, and everything, of course, to foster the reuse of the existing knowledge. Of course, then you can publish information, you can assign a DOI, you can put that information in different platforms in EOSC like Sonodo or B2Find, as you will see in a moment, to monitor and follow how the research object is being modified by others. For example, get notifications. You can also build reputations and find additional researchers based on similar works. So these are the added value. I will just not go into all of these details, but basically the most important part is the research object platform is integrating additional added values like text mining services, or EOSC, of course, integration with the core, like authentication of the EOSC, but also Sonodo, B2Find, in order to allow all of these different capabilities to, of course, not only expand the capabilities of research object management, but also to bring a bit of closure in the gap between all of these different services that are already existing into the EOSC ecosystem. So this is the ROHAB in details, a high-level view of the architecture. Of course, not necessary to go into details, but it's like The main technologies behind this, including, of course, semantic technologies for the management of information that we are generating, the metadata that we are collecting that is in some kind of machine readable form. And these are the resources that you can use to get additional information, to go directly to play with the Arrow Hub, get some tutorials, play with some Jupyter notebooks, and of course, to get some additional help via the help desk or support email. And with that, I finish here. Thank you very much.
Then our next speaker is Alex Ioannidis from CERN, who will give us a little tour of Sonodo.
Okay, and now you can hear me as well. Yeah. Okay, let's start. So I will be presenting Sonodo in this in the context of aggregators. I think I won't spend very much time. I won't steal too much of the time, since many of the other services presented here are much more into this into aggregating our resources. So I think I will present Sonodo from the point of view of how this is something that is easily fits into this this ecosystem of aggregators, and how things what kind of steps are done to make this happen. So for those not familiar, the basic offer of Sonodo is that it's a platform to upload and data set, software, or any type of material. So we're basically the premise is that any type of file format is accepted. We offer a very liberal, let's say, quota for data sets that are coming in up to 50 gigabytes. So authors easily upload the artifacts, they describe them. So we have a very rich but also flexible metadata schema. So we want to get the basic minimum, let's say, but it's still very much possible to expand and link to other objects and add very more complex metadata about the elements. We provide the UIs for this object, and these are available also before the publishing of the objects. And then the final step, let's say, it's the publishing itself. So authors and data publishers, they get a citable DOI, and they can export also these records into many other different formats, and which can be then harvested by other systems. And that's a very key point in this of being part of an aggregators ecosystem. So it's the export formats and what kind of connections are being made with other systems, and then to kind of take this a step forward and in terms of what comes next. So content on itself is let's say discoverable by basic metadata attributes, but always fits probably in some other context. For example, there's projects, there's other projects, or maybe some specific subjects, or even institutions or nations, or even conferences that happen and deposit artifacts and Sonodo. So the idea there is to collect all of these things and create these mini repositories, let's say, inside Sonodo. This is done via the feature we call communities, and these are managed by users themselves. So this is a way to for users to kind of organize what they upload and curate what basically goes into the into Sonodo. Then I think an important part of this, because these are different groupings that we make, but a major grouping and a major point here is basically funding. So how to connect projects and outputs of the projects with the funding. And that's an important aspect that basically then aggregators can feed on and create, let's say, meaningful dashboards about what are the outputs of funded projects. So basically, we integrate with the project database that comes from OpenAir. So we have almost 5 million grants for many different funders, also European, but also many different agencies. This can be linked to uploads, and they get displayed and then exposed via meaningful metadata to via our services. And basically, this as an auto record page is a very easy entry point to going to OpenAir Explorer, which is basically the gateway to be able to see how things fit into this larger ecosystem, let's say, of aggregators and funded projects. Then we provide, of course, we have other concepts to aggregate basically to collect, let's say, the evolution of research objects with time. So data sets evolve, they get new versions, software the same, papers as well, and they're live objects that evolve as time goes by. We try to collect statistics on these objects, and we try to aggregate them as well into again something meaningful and metrics that actually can measure basically the impact. And again, all of these are also exposed by our APIs. And then I think the last point and what the most important, let's say, point from this is that all of our features and everything we develop on Sonodo it's with a REST API first mindset. So it's made to be harvestable. It's meant to be machine readable first before being human readable. We have OAIP and Mage APIs for harvesting parts of Sonodo. And again, this is there's arbitrary sets that we have, for example, all open access outputs or all data sets. Or again, then we go to specific communities on even more fine-grained, let's say, sets. Another important aspect here is besides the documentation is also what kind of available formats we have. So again, there's no one size fits all. Different platforms work and parse metadata in different ways. So we expose many different metadata formats like JSON-LD, DataSite, uplink, or DCAT. So all of these are meant to basically increase the scope and the surface of what others can, how others can access a node and how others can harvest and obtain this this information. And I think that's it. So any questions here?
Yeah, so we're collecting all the questions in Slido still. I don't know whether we have any yet. I don't think so. So feel free to post something there while we continue with Claudia Martens, who will present B2Find.
I'm going to say something for B2Find, which is a discovery portal and part of DICE. DICE, again, is the data infrastructure capacity for EOSC and offers a lot of services that cover all areas of the research data lifecycle, like a lot of services or aggregators we just heard. Something doesn't work here. As I said, it's a discovery portal for research data, so not mainly for code and definitely not really for publications. We currently have roughly 1.5 million records in B2Find from 49 communities, including more than 130 harvesting endpoints. And it works in a way that when you click on b2find.eu.eu, you enter on a free text search field where you can enter any free text term you want. We take foraminifera because that's obviously very often used. Then you get a search result page containing all the records that relate to the specific term. And then you can start narrowing down the results using all the facets. We have currently 13 facets displayed on the productive B2Finds. What you see here is that spatial temporary coverage, publication year, communities, keywords, creator, instrument, discipline, language, publisher, contributor, resource type, and open access are facets. What differentiates us a bit from others are, I believe, the temporary coverage and the instrument and the discipline. B2Find was also developed nearly 8 years ago now, so it is something that grows, and the demand for having something where you can search for temporary coverage or instrument is just raising. And here you can click on and then start to narrow down even more. 2 words about identifier. Now my daughter is coming. We have a kind of ranking for identifiers within B2Find, and this is due to the fact that even the usage of identifier changed within the last years. Now having a DOI is common. That has not always been the case, and B2Find was developed, as I said, some years ago when it was not common to have a DOI, but maybe another identifier. What we do is that when we retrieve any DOI, we display it as DOI. When we retrieve any other persistent identifier, whatever that is, we display it as the PID. If we get nothing except any world source we will display it as source. And if we get all, we will display it on the single result page, all identifier we have. B2Find is not only a search portal, but also a metadata aggregator. It works in a way that we have communities, as we call them. Those are the data provider from where we get the metadata records. We do a metadata ingestion, which includes a mapping, and then we upload everything to the web portal. This part here, so the harvesting part, is done with different methods. Of course, we prefer harvesting via OAI PMH because it's so easy, but we also do support CSW and, of course, REST APIs. And the Spark queries, so anything that refers to triples is only enabled in the beta version. This part here refers to the mapping. So we do support generic metadata reader, as they are called, with also Dublin Core Data Site, OpenAir, and EU.core. EU.core is a metadata schema for transfer of metadata within the EU.services, which are also part of DICE. We do also support thematic readers. So ISO is for georeference data, that's the Inspire directive more or less, and DDI is for mainly social sciences. The point here is that what we always do, we do support very specific metadata schemes which are not offered in a standardized way. This is valuable insofar as it enables to search for data which are not displayed otherwise. And then finally, what we have in our web portal is harvested by OpenAir. So the transfer metadata schema here is DataSite, then adapted to the OpenAir guidelines. So everything that is in B2Find is automatically also in OpenAir. I think this is not really important, let's say, for big data provider who are already very, very good in dealing with data and metadata. But it is very important for communities which are very small and do not have any other support for opening their research data in a different way. And with that, I would like to finish.
Okay, then Anne, I think it's back to you.
So I'll share my screen for the demo. And we will start from the OpenAir Explorer. And for instance, I will start to search from the Copernicus air quality, which is what I'm interested in. And as I mentioned earlier, what is very useful for me is to be able to find different types of research outcome. And I have publication, research data, software, and other research products. So for instance, if I click on software, I will have much less hits, but I can see, for instance, some of the resources that could be interesting for me. If I click on that one, which is what I'm interested in, air quality, European air quality analysis from Copernicus Atmosphere Monitoring Service. This is a resource created by Simone. It has been published in Sonodo, and it has a digital object identifier, and it's open access. So I can click on this one. It has many more information, a summary, description, and it has additional metadata. And in particular, it has this metadata information saying this is an EOSC Jupyter notebook. And for this reason, a service, an EOS service can be associated to it, which is the EGI notebook. So when I click on the EGI notebook here, I can directly access the resource, but for this, you need to have access to EGI notebook. If you haven't requested access, you need to place first an order. Of course, I have done it, so I have already access to the resource, and this is what you would get. You can upload like the Jupyter notebook I found in the OpenAir, and the first thing, as I mentioned earlier, I would do is to rerun and restart all the cells, and I want to get like a reproducible Jupyter notebook, so get the same results as the one published earlier. So I go quickly because the demo needs to be short. And I would get, for instance, something like that. I would have like a plot where here this is a particle matter for particles smaller than 10 micrometers, and this is for 3 different years for September 2019, 2020, and 2021, and it's over Italy. It's great, but as a researcher, I usually want to start from this Jupyter notebook and to create derivative work. And for this, I can copy this Jupyter notebook and I can customize it, and I can start to collaborate with my colleagues. This is normally where we start to work together, and this is where I will use the EGI Data Hub for sharing the data I'm producing, but also the data I'm using and ingesting in the Jupyter notebook, so that everyone can work on the same data and with the same computational environment. And I will customize it, for instance, to do another type of analysis. So here I will do it over Spain, and I will do it for different months, for April. And I will use a different variable. I will use nitrogen dioxide. And the rest will be identical. I will get data, for instance, from the Adam platform, from DataCube. So it's very handy to select data. And again, I go very quickly. Oops. And I will get something different, but very similar pattern, like a plot. This time, this is for nitrogen dioxide, and this is for April 2019, 20, and 21. And I could see, for instance, the impact of the lockdown, because in April, this is quite a bit lower than for other years. And the next step would be to share. If I want to be findable and accessible, even if I already put the data in the EGI Data Hub, someone needs to be able to search and find them. And for this, I use RowHub and the research object. So I will create a research object out of my work. So if I go here in the RowHub portal, this is where I would like first my research object to be available. So I can create, oops, and I can do it here. I can create a research object, so I need to authenticate to RowHub, and I need to create a new research object. We'll do a few things here, and we go here, and I can explore. So this is public, so everyone can access to it. Yeah, and we see a new research object that has been created with no resources. If I click on the view, I can see already I added an author and I added the collaborator, and we can see Simone, who originally shared the first Jupyter notebook, but there is no content yet. It is already citable, but I can add some more information. I can add contributor, I can add a publisher, I can add a license, which is an MIT license, and then I will populate the research object with all the different data I have generated, so the input data, the output, etc. So I will just do it here quickly. And I will show you first. So the data we share is in this data hub. Yeah, this is like a folder, standard folder. And it will be, for instance, this one. And I will have the input, output, and tools. And I find exactly the same here. I have the input, output, and tools. And when I will populate what I have put in the inputs, which is the input data used in this Jupyter notebook. And in the outputs, it will be what I generate from this Jupyter notebook. And I will share it immediately in this one. So here, if I refresh, if it has been executed already, oops, I should see already, yeah. So I see a sketch, which is like the main picture, and I see already some data being shared in the input folder and in the output and in the tools. I will share the Jupyter notebook I'm using right now. And for instance, if we take one of these links here, we can see this is data that are shared in the EGI Data Hub, so anyone can access the data at any time. And then at some point, when I'm happy with that and we are collaborating all together, we will publish it in Sonodo, for instance, and get a digital object identifier. One other aspect is without doing anything, new metadata will be discovered thanks to the text enrichment metadata service from the Reliance project, which will be help me to be more like findable or accessible by others, because there will be more metadata added to my research object. And that's it for me. I will stop here, maybe sharing.
Thanks a lot. Then we're accepting questions via Slido, and I think I already saw one question there. Someone is asking, when reusing software or a Jupyter notebook, how do you manage the computational environment, and where do you find the necessary compute resources? So more about compute than about aggregation. And I'm assuming that question is more for you, Anne, because someone really is asking a question about your workflow there, I think.
Yeah, so if I understand clearly, the question is more, yeah, the computational environment for us, this is like the packages, Python packages we would need to execute an existing Jupyter notebook. And for now, this is added directly in the notebook. So we like pip install packages, or we add packages manually. And we also share in the research object an environment file with all the list of packages you would need to run the Jupyter notebook. I don't know if this is what is expected in terms of answer.
I don't know whether that makes it clear that the person can always unmute themselves if they want to. No, is it clear? For now, we have no other questions. I don't know whether there's anything else that anyone wants to ask. You can still put it in Slido. If not, in I think it's the same anonymous as before, Anne. Someone is saying, what about the necessary compute resources? I think that's a follow-up question.
Okay, that's a very good question, because that's a bit critical. So the computing resources now in the EGI notebook are predefined before you start the Jupyter notebook. So you can select like the flavor, and it means it has been pre-configured. I don't know if anyone else, like Raoul or someone else, would add something about it, but for now, this is not very customizable, and this is critical for us. It's a
yeah.
I cannot. Yeah. Okay. Go ahead, Raoul.
No, okay. So I was just going to say that in the case of EGI notebooks, the way that we operate is, of course, you need to create first an account in EGI notebooks, and depending on the community that you are part of EGI notebooks, that's the different environments that you can get access to. So in the case of Anne, for example, she's part of Reliance community, and Reliance, we have a virtual organization in EGI notebooks that we have 2 pre-configured environments that our researchers can choose from. If we need more resources, or we need, if we have some requirements from the researchers, then we just need to contact the EGI notebooks team and ask them to create additional environments. And we are now, for example, in the discussions how to customize also the number of, not the number, but the libraries and the environment itself that is loaded once you select an environment. That's, yeah. Paulo.
Yes, no, we just mentioned what I wanted to. So there is basically, as a scientist, you have 2 options. Either you go straight to EGI, you or the resources, the computing resources, which means you're applying to be served with some kind of resources, and then you deploy the engines, and then you use the Jupyter notebooks on the engines, or otherwise you get Jupyter notebooks engines as a service, basically, and that's the idea behind EGI. So they pre-allocate some resources for you ready to go with all the environment that you need, and then you can do what is needed to perform your sites. And this is a quite common scheme, in fact, that applies to many other software as a service in general, or environment as a service, if that was the question.
Okay, I hope that makes it a bit clearer. I don't think we have any other, oh no, we do have another question. I just saw it pop up. I think it's another follow-up question. You can unmute yourself, so don't hesitate to do that. But so this person is saying,
okay, the question is clear. The question I think is clear. So as far as I know, yes. So you need to go to the EGI ACE entry points where you will find instructions on how to order your Jupyter notebooks. I don't think you need to be part of the community. Maybe you will be limited in terms of the resources that you can have access to. I know they provide them with a few gigabytes of RAM, etc. So try and give it, take a look at it and give it a go and see what happens. But you can, yes.
Yeah, I would also say that you should try to see this from the marketplace. I mean, there is you know, if you go to the marketplace and see EGI notebook, this is you can get access to the resource, then make the request of resources that you need and so on. So you can also go via the marketplace if you need.
Okay, I'm hoping that's clear. No new questions come in. I would like to wrap up. I would really like to thank all of our speakers. We have another one of these sessions planned next month, which is on HPC and specifically on how EOSC is trying to link up and build bridges with HPC centers, which is not always straightforward. I think they're specifically talking about resource allocations there. So I'm hoping to see some of you again. Something that I would also like to draw your attention to is that we have an early adopter program that we have launched. I'm putting the link in the chat now, which is explicitly looking for use cases for EOSC resources and things that can either interconnect with the core or that want to use or that are using interdisciplinary resources. So I would say that the deadline for submitting something there is the 15th of May. So go and have a look and see whether that is a good fit for you. Thanks a lot to all of our speakers, and I'm hoping to see you again next month. Bye-bye, everyone.
Thank you, Catherine. Thank you, Catherine. Thank you all. Bye-bye.